Okay, so today we are going to uh, go over section 10.7 titled Graphing Polar Curves. So for this section, we're going to focus on a few important polar functions. Think of them as your parent functions. You can always graph any function by making the t-table. However, we're going to go over some of the more popular ones. So we're going to start with circles. Okay, so circles are always going to be of the form r equals either a sine theta or r equals a cosine theta. Whenever it's a sine function, remember sine is an odd function and cosine is an even function. So for circles, whenever you have a sine function, you're going to have symmetry with respect to the, so instead of with the origin or instead of with a y-axis, we don't have anything like that. The symmetry of these graphs is going to be just symmetry with respect to the vertical axis. We don't really have vertical axis. It's more like the line theta equals pi over 2. But we're going to use the term vertical axis because it really hits at what we're trying to show. And then whenever you have cosine, you're going to have symmetry with respect to the horizontal axis. Okay, so then to get circles, you can always get a circle with r equals and then any number. That's going to get you a circle in the center. So you can have r equals 4 or r equals 10. You're going to get circles, right, with a center at the pole. But that's not the ones we're talking about right now. We're going to talk about circles that are offset. So to the right of the vertical axis or above the horizontal axis or whatnot. And you get those with r equals a sine theta or r equals a cosine theta. The diameter of those circles is going to be your a value. So the a value stands for, that's the diameter of the circle. So the radius would be a over 2. All right, so let's try an example. Let's start with r equals sine theta. Okay, so like I said, you can always make a t-table, but I'm going to do something better than a t-table, something we call our helper graph. We're going to graph y equals sine theta and then move those points over to the polar graph, the polar plane. So for our helper graph, y equals sine theta, it's a sine graph that goes from 0 to 2 pi. You have your midpoints and your quarter points, your max and your min values. So those points are going to help me, especially what happens in between the points. It's going to help me figure out what the graph looks like in polar form. Okay, so for your polar graph, we can start with 0, 0. At 0 degrees, the r value is 0. At pi over 2, the r value is 1. Okay, so I'm at 2 dots here. In between those values, the output is increasing, so your r value is increasing. And then you go back to 0, but this time they're decreasing. So now we have a circle. We have a circle with a diameter of 1. Notice how we have symmetry with respect to the vertical axis. Okay, because we have a sine function. So let's try another example. Let's say we had example 2, the graph of r equals 10 cosine theta. So we're going to do the same thing and start with a helper graph. Okay. Let's start with y equals 10 cosine theta. So our max is 10, min is 10. We're going from 0 to 2 pi. And start at the max, equilibrium, minimum, equilibrium, maximum. So when we try our polar graph, and I don't know why I chose 10, but you know what? You can rescale your graph. So each ring can stand for 2. Okay, so then at 0 radians, we're at 10. At pi over 2, we're at 0. And in between the two, our R values are decreasing. If you want to choose a value in between, let's see what would get us 5. At pi over 3, the cosine of pi over 3 is a half. So at pi over 3, we get 5. So we'll point somewhere over here. Obviously, my graph is not the best graph. I should have, all my rings should be equally spaced, I guess. Okay, so somewhere in between, we get 5. Well, not somewhere, at pi over 3. Okay, so this is what this 10 cosine of theta graph looks like. It looks like a circle. Look at the symmetry with the horizontal axis. Okay, diameter is 10. So our diameter is 10. The A value, our radius, is 5. So this is what circles look like. For homework, I want you to make some flashcards with in the front something that says circles, and it has, the equations. And in the back, I want you to put some properties, okay, and some examples of r equals a sine theta, r equals a cosine theta. Also, so this should be 2 flashcards. So I need 2 flashcards. Okay. The end.